Hey everyone, today we are going to work on the investigation for lesson 4. The unit that you're in is about states of matter, and this lesson is about the motion of particles in the different states of matter. So think back to a demonstration that we did in class a couple weeks ago. Your teacher had a glass of hot water and a glass of ice water. We put red food coloring in the hot water and we put blue food coloring in the cold water. Remember what happened as we watched those for a minute or two? The food coloring really quickly spread throughout the cup of hot water, and it took much longer for the same food coloring to spread through the cup of cold water. That has to do with the motion of the particles in the glasses of water at different temperatures. And in this investigation, we're going to explore that in more detail. So here's the phenomenon, the big idea for this lesson. Drops of food coloring dissolve into water at very different rates depending on the temperature of the water. In investigation 1, we are going to work on modeling states of matter. You probably use the term temperature to describe the weather or even your food. Although terms like water, warm, cold, and hot are great for everyday language, the scientific meaning of temperature has more to do with particles, their motions, and the energy involved in those motions. To start, come up with your own model of the 3 states of matter. Think about the images you see here and the unit anchoring phenomenon. The ice eventually turns into water when it's left out, and water boils and seems to disappear when it is heated. What components or parts should be in your model, and what is the relationship between those different components? Pause the video for a minute and think about how you could model the 3 states of matter, maybe with your body or a drawing or some sort of prop. What did you come up with? Scientists use the Celsius scale to compare the temperature of objects. There are other temperature scales, but the Celsius scale is the one most commonly used in the study of matter. Why do you think it's important for scientists to use the same temperature scale? Answer this question on your lab sheet. The Celsius scale is the most commonly used temperature scale in the study of matter. It's based on the behavior of water. The Celsius scale is sometimes called centigrade. Use that information as you think about your answer. Why would we want scientists around the world all using the same temperature scale? Pause the video and respond. A state of matter refers to the arrangement and motion of the particles that make up a substance. The image here shows water in 3 different states of matter. In the top diagram, we have water in the solid state. We call that ice. In the middle picture, we have water in the liquid state. We call that water. And then in the bottom picture, we have water in a gaseous state. We call that steam or vapor. What kinds of particles make up water in each of these states? Did you guess water molecules? You're right. Notice that at the atomic level, the particles all look exactly the same. 1 oxygen atom and 2 hydrogen atoms bonded together. How does the macroscopic shape of water in each state differ from the others? That means, what does it look like on a bigger scale? Did you notice that in a solid state, ice, it keeps its shape? In the liquid state, water has no definite shape. It will change to fill the container it's in, but it does have a definite volume. The same amount of water, the amount of water will be the same when you move it from one container to another. If you have 10 milliliters of water in one glass and you pour it into a different glass, you'll still have 10 milliliters of water. And then in the gaseous state, water seems to always be changing its shape. It will fill the container that it is in. The volume can also change too. Pause the video right now and complete the table on your investigation guide with that information. Welcome back. Let's look at a few more questions. How does the arrangement of particles in each state differ from the others? Do you notice how in a solid state, the particles are packed really close together and they vibrate in place? They do not have freedom to move. In a liquid state, the particles are still arranged, but it's much more irregular. They're just kind of piled on top of each other here, and they have more freedom to move. And then in a gaseous state, there is no pattern whatsoever. How does the motion of particles in each state differ? Well, Particles in a solid can only vibrate in place. Particles in a liquid can flow past each other. That's why when you turn on the faucet or you pour water out of a container, it flows in a steady stream. And particles in a gas are very high energy and they move independently and at random. Pause the video again and add this information to your table. Hello again. Let's look at a few more things. Let's talk about changes of state. The state that matter takes depends in part on its temperature. At what temperatures does water change state? Well, water changes from a solid to a liquid at 0 degrees Celsius. In general, water below 0 degrees Celsius is a solid. Water at a temperature between 0 degrees Celsius and 100 degrees Celsius is a liquid, and water above 100 degrees Celsius is a gas. Remember how we said earlier that the Celsius scale is based on the behavior of water? This is why. What are the temperatures at which a substance changes state from solid to liquid and liquid to gas called? When water changes from solid to liquid, we call that melting, and that temperature is the melting point. You've heard that word before, right? And since the process of changing from a liquid to a gas is called boiling, we call that temperature the boiling point of a substance. Which state do you think requires the highest temperature to reach? Did you guess gas? You're right. Again, pause the video and add this information to your lab sheet. The next step for this investigation is to use this simulation. It's linked in your investigation sheet, and there are some hints. Make sure, first of all, that you click that link to load the simulation. Then, of the 3 options here, choose states. And over on the right side here, make sure that you set your substance to water. You'll see the little water molecules here vibrating around. You can change from solid to liquid to gas using these buttons. You can also add heat and pay attention to how particle movement changes as you add heat to the different state of matter. You can cool it off, allow heat to leave the substance and go out into the environment. There is a pause button here if you need time to look at anything or record any ideas, and you can reset the whole simulation here. Just make sure that if you do that, you change it back to water. Once you've completed your investigation and answered the questions using the simulation, then you will want to take a couple minutes and play around with some of the other substances listed here if you've got time. So to wrap up, how is it that the temperature of a substance determines its state? Well, as the temperature of a substance increases, the particles of the substance move faster. This is what causes the change in state from a solid to a liquid and then to a gas if you continue adding heat. How does microscopic behavior of molecules affect the macroscopic behavior of a substance? In other words, how does what those individual molecules are doing affect what the substance looks like when we view it with our eyes? Particle motion determines the state of matter, right? Solids are locked in place and vibrating. The substances that are solids are rigid. Liquid particles move more loosely and more freely, so they can take the shape of their containers. And gas particles move about very freely, so they fill their containers. Then you will watch the States of Matter wrap to get some ideas for how to use your body or other props to model particle motion, and you need to respond to your teacher's post in Flipgrid with your own idea. Make sure that you post a video of all 3 states of matter and how you would use your body or props to show how particles are moving in those 3 states. Use that States of Matter wrap if you need ideas. Good luck!